Hello, in this video we will be deriving Marshallian demand curve through both graphical and numerical approach. For a graphical approach we will draw two panel figure in which first panel will show the shift in the budget line and a consequent shift in the indifference curve or choice of the consumers, and in second panel we will finally draw or finally derive the demand curve. So now let's begin. I will draw x-axis and y-axis, and let's derive the budget line and an interpretation curve IC1. And since we assume that price of x has decreased and x and y good are normal and means normal, uh, then when the price of good x decreases, the budget line swings outward from, let's say it's A to B. Let's name this D. From AD to DB, it swings outward, and consequent shift in the IC is seen. Let's name it E1. Let's name it E2. This is the first panel we have drawn. Let's it's A. So now let's draw panel 2. It's Y. It's not Y. It's X. Sorry. We will draw. We will write here. It's price of good X. It's good X, and we will draw a line straight downward from E1, and we will term it QX1. And similarly, we will draw a line straight downward from E2, and we will name it EX2. Since the price has decreased, we will that initially the price was PX1 and quantity demand was at A, and price has decreased from PX1 to PX2, so the demand has increased from QX1 to QX2, and let's name it point B. If we join point A and point B, we get a downward sloping Marshall demand curve for good X. It's so simple. First we drew the um, budget line, and we will show the shift in budget line due to change in the price of good X. And in panel B, we will derive the demand curve. So now for numerical approach, we will assume the utility function as u equals to x1 x2 subject to constraint budget b equals to p1 x1 plus p2 x2. Now we will set up Lagrangian function as z equals to x1 x2, and we will normalize our subject to constraint such that lambda times b minus p1 x1 minus p2 x2. So now we will partial derivative or partially differentiate this equation. Let's name this equation 1 with x1 x2 and lambda, that is del z divided by del x1. We will get x2 plus and when we differentiate x1 and x2, we will assume x2 as constant. So if we differentiate x1 dx1 with dx1, we will get 1. It's 1 plus lambda times and if we multiply this lambda with b, our income coefficient, then this whole term will be constant, so its derivative with respect to x1 will be 0. Similarly, if we multiply lambda with p1 x1, we have the term x1, so it will be lambda times p1 times 1, and for this last term it will be 0 since there is no x1, and we will write equals to 0 because of first order condition. First order condition. Similarly, for dz divided by dx2 equals to, we will get x1 minus lambda p2 equals to 0. And for dz divided by d lambda, we will simply get by b minus p1 x1 minus p2 x2, and we will set it to 0, and let's name it as 2, as 3, as 4. Now we will solve 2 and 3. If you solve 2 and 3, if we solve equation 2 and equation 3, then we will get the consumer's equilibrium. That is x2 minus lambda p1 equals to sorry, we must first find the value of lambda from here. We'll got lambda equals to x2 by p1, and we'll get lambda here. Lambda equals to x1 divided by p2. So finally solving this to lambda, we will get x2 by p1 equals to x1 by p2, these two lambda, these two lambdas, and let us that x2 equals to p1 by p2 times x1. This is the and we will derive the value of x2 in our equation 4 such that b equals to px1 plus px2 equals to px1 plus p1 p2, it's p2 times p1 by p2 x1. This is cancelled, it's 1, it's 2, P1 x1 equals to B, and x1 equals to B by 2 P1. This is the required Marshallian demand curve for x1. And similarly for x2, if we derive this, if we substitute the value to x2, we will get x2 equals to B by 2 P2. So now let's recap. This is the utility function, and it is subject to constraint b equals to p1 x1 plus p2 x2, and we will make the Lagrangian function such that z equals to x1 x2 plus lambda times subject to constraint in a normalized form, that is b minus p1 x1 minus p2 x2. So now we will partially differentiate the Lagrangian function with respect to x1 x2 and lambda. We will respectively get the values as x2 minus lambda p1 equals 0 using first order condition, and when we solve this equation we will get lambda equals to x2 by p1. Similarly, if we partially differentiate z with respect to x2, we will get the value of lambda as x1 by p1, x1 by p2. Finally, if we differentiate z with respect to lambda, then we will get our normalized constraint. And now mm, solving for the lambda, we will get the consumer's equilibrium, and from here we will find the value of x2, and we will finally substitute this value in our equation 4. By substituting it in equation 4, we will get the Marshall demand curve for x1. Similarly, if we derive this value of x1 in our previously obtained relationship between x2 and x1, we will get the Marshall demand curve for x2 as B by 2 P2. Thank you.